Good morning, everyone. We're at that part of the course that we see that this really is a true pre-calculus course. And what I mean by that is the last several topics can sometimes seem to be random topics. They don't build on each other as much as maybe our previous math experiences. I'll try to make the connections the best I can, but in some cases, these are just a variety of topics that if you are going to be taking a further math course, especially calculus, you need to be somewhat comfortable with these. We just completed working with, polar coordinates, polar graphs, understanding the basics of those, and in future courses you may need those. The next little section, which can be somehow connected to those polar graphs and trig, but in other ways maybe seem very different, is going to be dealing with vectors. Very much a physics-oriented type of a topic, so if you've had a physics course, you're going to be a little bit more prepared than if you haven't. But let's get down to the basics of vectors. A vector is something that we're going to define as a quantity with direction and magnitude. Now, quantity can mean a lot of different things. It could mean, of course, length, and that's what we like it to mean. But quite often it could mean any other type of forces. It could be a speed or velocity. And then the direction, of course, is where is it going. So when we see magnitude, that's going to be basically its value, its measure of the quantity. So if I'm going 50 miles per hour, that could be 50. If something weighs 600 pounds, that could be 600. In which direction am I traveling that 50 miles an hour? That, of course, would be the direction. Weight is always going to be a direction towards the earth, or towards the center of the earth, or towards the ground, so that would be its direction. But we'll get more into that as we go. First of all, let's talk about some of the notations. We have various notations for a vector. It could be as simple as we see this little ray type situation. Many times we're going to be denoting vectors as small case letters. We usually use V, U, maybe R, S, T, some of the latter parts of the alphabet. Many times we also put a little vector symbol above it, which is kind of a half ray. We could talk about a vector going from point A to point B. And even though that looks to be a line segment, we need to have an arrow on it that's going to indicate direction. So this could be vector AB. Also, you'll many times just see these in bold letters in print, so be aware of that. So what are we going to do with some vectors? Well, one of the things is we're going to be able to, add and subtract vectors. Or maybe just plot a vector. Let's say graph a vector. Now, graph might imply that we want to put it on an XY axis, and we can do that, and we will superimpose it so we can understand direction and magnitude a little bit better. Another thing we might do with vectors is add or subtract vectors. Another thing would be involve what we might call a scalar multiple. And we'll talk about some of these different things. Magnitude, what is that? Well, as far as notation for magnitude, if I want to talk about how long is that, I'm going to use kind of double absolute value symbols, basically, and that's going to indicate magnitude. There are other ways, but when you see this, don't get freaked out by the notation. It just means the magnitude. Again, if I'm going 50 miles per hour, the magnitude of the vector would be 50. Couple other things. We're going to deal with something called a unit vector. Now, unit vectors can basically be our I vector and our j vector. And there's some other notation for a vector. And this is more of an algebraic way of looking at it, but let me not get too far ahead. So let's just take a couple situations here. Let's say I have this vector. And I'll call it R. And then I have another vector, and I'll call it S. and I want to find r plus s. Well, geometrically, this means pretty much what it kind of says. We're just going to take r, and then we're going to add s to it. So I just kind of pick that up and move it over here. And what we end up with is something we call the resultant. And we've talked about this a little bit before, but that's how we put the two vectors together. Now, one thing I probably should have done, let's make this v and this v, because quite often we like to talk about the end result as that r vector or the resultant vector. So I'll try to stay consistent with that. But that's kind of the geometric way of adding, or we could work with subtracting vectors. If I wanted to find, let's say, 2v, well, 2v is just going to be one of them, and then another one. So this whole thing is basically 2v. If I want negative s, I'm just going to go in the opposite direction. And again, these are the basics that I'm sure you can read about and be somewhat comfortable with. There's also something known, and this is probably the biggest part of it, as a position vector. A position vector is basically a single vector that if we wanted to start at one point and move to another, we create a vector in order to do that. For example, let's say that I have A is going to be the point -1, 2, and B will be the point 4, 6. All right, and I want to find a position vector for AB. Well, the position vector for AB is nothing more than basically the back subtraction of its components. So we could think of it as like x2 minus x1 is the new x, and then y2 minus y1. So this is where you want to end up, and this is where you start. So in this case, it's going to be 4 minus a -1, which would be a 5, and then 6 minus a 2, which would be a 4. Now, one other way to use notation for a vector when it's in this type of a form is maybe an ordered pair, but quite often we see these kind of squared off parentheses. So that would indicate a vector. So if I would plot this point on an xy axis, plot this point on an xy axis, this basically is creating a vector that would go from A to B. Now, if I went from B to A, you might realize these are just going to both be negative. They would be the opposite. Now, what we can do then is we can use some of this to be able to work with the algebraic way of dealing with vectors. The other thing is if now I think of this as just a simple position vector, I end up with a nice little picture. If I went 5 and 4, I'm thinking of the vector now as just being this. And that vector, AB, obviously has a magnitude. And it also has a direction. Its magnitude is just going to be based on the Pythagorean theorem. It's going to be the square root of this squared plus that squared, so 25 and 16 be 41. So we can use all of our simple trigonometry, geometry, other stuff that we've learned throughout this year. If I did want to find the angle, I could find that without too much trouble. Again, using sine, cosine, tangent, whatever the case may be. So I could say that the position vector has a magnitude of radical 41 at an angle of whatever this might be above the x-axis or in our normal rotation. I'm going to stop there for for the first part of this. I'm going to come back in just a few minutes with a second part that will have a lot more examples. But up to this point, a vector is nothing more than a quantity that has a direction and magnitude. There are a variety of notations for it. Ultimately, what we want to be able to work with is to be able to find magnitudes, add, subtract vectors geometrically, but also analytically, algebraically. In order to deal with them algebraically, we like to work with position vectors. That's going to be one of the keys. So stay tuned for part 2 of the lesson from 10.4.